Alright, I think I'm recording. These are problems that I gave you guys to prepare for your first quiz on Friday. Let's go ahead and take a look at these problems. In problem number 1, it asks us to do a division. So there's different questions that you need to ask yourself at the beginning of each problem to see if it's set up and ready to go. Are these terms in descending order? So when we look at the exponents, 3, 2, 1, and then a constant, and in this problem, yes, they're in descending order. Are there any missing terms? Well, we have a cubed term, a squared term, a first term, a constant term. If any of those were missing, if we didn't have an x squared term, we would have to put in a 0 as a placeholder. But we don't have any missing terms for this problem. We would like to do this division with synthetic division because it's a shorter, easier pattern than the long division. The long division will always work, but the synthetic division only works if the denominator, if this divisor, is of the form x plus or minus c. You have to have a 1 here. You can have addition or subtraction of any number. So it has to be a 1, and it has to be x to the first power. It can't be x to the second power. It's got to be a binomial, 2 terms, and that first term has to have a leading coefficient of 1, and the exponent on the variable has to be 1. Then you can perform synthetic division. Synthetic division has a pattern associated with it. We've seen that in previous examples. Here, when you look at your numerator and you look at the denominator, if you start with the denominator, now I put this in a box in previous note. Yeah, it's in a box down here. That what goes in the box is the opposite. It says x plus 1. The opposite of positive 1 is negative 1. So it's always going to be in the box is always going to be opposite that number in the denominator. Now, these numbers in front of your x's are called coefficients. And you come in and peel off, take the coefficients and write them down as well as the constant term. You leave yourself some space underneath these numbers. The first number, it may not always be a 1, but that first number that's here in front of the leading term will always come straight down below a horizontal line that we draw. And now, if there is a number below that line, we multiply it by the number in the box, and we write it underneath the next column. We add these together. Adding is different. In long division, you subtract, but in the synthetic division, you add. So in this case, a 1 would come down. A negative 1 times a positive 1 is negative 1. You add 3 plus a negative 1, you get 2. It's below the line, so it gets multiplied by the number in the box. If we come down, negative 1 times 2 is a negative 2. And 5 plus a negative 2 is 3. That last number is always your remainder. So here, below there, this was to illustrate the pattern, and here I filled in the values. Now the 1, 2, 3, that's going to help us with our final answer. You can go at it from right to left. This number is always the remainder. You're always going to put the remainder in the numerator of a fraction, and the denominator is always going to stay the same. Oh, we're not doing that problem. We're doing this problem in just a second. This is our example. This is our practice for our quiz problem. Right now we're just talking from the notes, trying to remember the pattern so that we know what to do with the problem that we have. So this 1, 2, 3, we're going to use that to write our final answer. That 3 is always the remainder. It it's always the numerator, and this denominator, x plus 1, has not changed. Now, if you go at it from starting on the right and then move here, the exponents will start to increase. There is no exponent, so 0, and then the first power and so on. Or if you start on it from the left and write it, look at the degree of the numerator. The biggest exponent here is 2. The degree of the denominator will always be 1, so it's always the biggest exponent minus 1, and that's what you'll start it with. And you can see that 2 minus 1 is 1. Alright, so then we have 1x plus 2 plus our remainder, and that's always that remainder divided by my denominator. So now, knowing that problem, try to do this problem. Pause the video, try to do it on your own, then come back to the video to check your answer. So hopefully you put a 3 in the box because that says -3. Let's back up. Make sure that I'm in descending order. 3, 2, 1, and the constant. There's no missing terms, but we went through all that here for that problem. But I'm just re-emphasizing, just kind of going through my head, because every time I see that, it's a repetitive process. I start with those initial questions. So I can write a 1 here to help me to know that I start with 1, then a 6, then -21, then -18. I give myself space here. I'm going to write some numbers underneath here. So I draw a horizontal line below that. This first number always comes down. We don't add anything to it. We don't change it. Whatever this number is here, it's going to be the first number in our answer, our leading coefficient. This number is below the box. Below the line. So 3 times 1 is 3. We write it underneath the next column. We add these together. This number is below the line. We multiply it by 3, the number in the box. 3 times 9 is 27. We write that underneath the next number. We add these numbers together. And remember, don't make silly mistakes. If you have to use your calculator, that's fine. The minus sign, the negative sign on your calculator is different than the subtraction key. So be careful of that. And then plus 27, and I get 6. That number is below the line, so we multiply it by the number in the box. The 3 times 6 is 18. Write that below our next number, and we add these together, and I have a remainder of 0. So my final answer, since this degree was 3, this degree is always 1, and 3 minus 1 is 2. So I start out with a 2 on my x squared. Then I go plus 9x. Then I go plus 6. For the remainder, always put it in the numerator, and even do it if it's 0, because it gets you in the habit of doing it every time. When this last number technically is 0, but that's fine to write it because you're establishing a pattern that you're going to use every time. Alright, so we have a second problem, and again, it's a division problem. Are the terms in descending order? Well, the exponent's 4 and then a constant, so yes, it's in descending order. Are there any missing terms? Well, yes. We start out x to the 4th and then jump all the way down to the constant, so we're going to have to rewrite this expression. We want x to the 4th, but we do not have an x cubed term, so that'll be 0x cubed. We do not have an x squared term. That'll be 0x squared. We do not have an x term. It'll be 0x. We do have our constant, minus 16. So this is going to be how we think of the numerator. It's equivalent. It's the same thing as the numerator that's written, but those zeros there are going to help us to line things up to get the right answer. The denominator, is it of the first degree, and is the coefficient 1? It doesn't matter whether we have addition or subtraction, just as long as it's addition or subtraction of a constant. It can't have a variable in the second term. So it has to be a binomial. It has to be two terms. And this first term has to have a leading coefficient of 1 and an exponent of 1 for us to do this. Alright. We talked about the pattern. You take the opposite of the number in the denominator. Now here, I'm recognizing my pattern from a previous example. X squared plus 3x plus 5. That numerator is in descending order. There's no missing terms. The denominator, I have a 1x to the first power. Plus or minus, it doesn't matter. It's a constant term. We look to that denominator and we take the opposite of that number, put it in the box. We take off what they call the coefficients, 1, 3, and that constant term of 5, and write it. Leave space and draw a line. The first number is always going to be the first number in the numerator, and that comes straight down. We don't multiply it by anything. We don't add anything to it. It's always the same. If that number is below the line, you multiply it by the number in the box and write it underneath the next number. You add. If the number is below the line, you multiply it by the number in the box, you write it underneath the next number, and you add. When you're finished, people are sometimes making the mistake of starting out and saying that this 1 is 1x squared. Well, when you divided, you lost a degree. So this numerator has a degree of 2. The biggest exponent is 2. The denominator always has an exponent of 1 in this synthetic division, and 2 minus 1 is 1. That's how I knew to write 1x to the first plus 2 plus my remainder. My remainder is always the numerator, and my denominator was the original denominator to the problem. Alright? So now, you should have studied those examples. You should know that pattern by heart so that when you come in here, you can recognize that yes, this is descending order, but I have some missing terms. I have 1x to the fourth. I don't have an x cubed. I don't have an x squared. I don't have an x term, but I do have a constant term. That is being divided by. Now we can write our division with this horizontal sign there and the dot above or below it, or you can write a fraction bar and put the x plus 2 in the denominator. Although those look different, it's the same division problem. Now, it might be smart to put a 1 there even. Figure out what number goes in the box. It's the opposite of the number in our denominator. The number in our denominator is positive 2. This is a negative 2. Now I look up to my numerator and I write the coefficient of 1, 0, 0, 0, negative 16. First number is always going to be the number that's in the numerator of my problem, because this first number always comes straight down. And every time a number is below this line, then I'm going to multiply it by the number in the box and write the result underneath the next number. 1 times negative 2, negative 2. I add these together. It's below the line, so I multiply it by the number in the box, write the result underneath the next number. If you need to use your calculator when you're multiplying these, do it. And even if it's small numbers, because we know that 2 times 2 is 4, and we're not going to make that mistake, but we might make a sign error. Now, in the synthetic division, we're always adding these numbers, 0 plus 4. It's never going to be 0 minus 4. So we have negative, the numbers below the line, so we go 4 times negative 2, write it underneath the next number. Add these together. The numbers below the line, it gets multiplied by the number in the box. We write it underneath the next number. We add them together. So we did the same thing and just kept moving to the right, writing the numbers underneath there. When we're done, this last number is our remainder and our answer. We look and say, hey, we started out with a degree of 4 in the numerator. The denominator will, for synthetic division, will always have a 1 because you can't do this synthetic division with an x squared or x cubed. We would have to go back and do long division if that were the case. But we just always take this number minus 1. 4 minus 1 is 3. So that 1 is x to the third. This minus 2 is x squared. I'm just going in descending order. Plus 4, x to the first. Now, minus 8, and even x to the 0 by definition is 1. We just normally don't write that there. We just normally have the negative 8 times 1. Then we make a fraction. Numerator 0, the denominator was x plus 2. This is our answer. So it's very pattern oriented. If you know the pattern, and if you make sure you don't make silly mistakes, the common silly mistakes are not recognizing you have missing terms, not changing the sign from the denominator, doing arithmetic errors, maybe subtracting or you add these numbers together. And then the big mistake that people often make is to forget to come up to that biggest exponent and subtract 1, and that's where your answer starts. Students have a tendency that, hey, it started out x to the fourth, I'm going to leave it x to the fourth. You can't do those silly mistakes. Those you'll lose those points, and losing those points will add up. These are easy points for these problems. You need to get all of the easy points because not everything on these quizzes and tests is going to be easy. So you may lose some points on the harder material, but as long as you're getting points on the easy material, in the long run, it should be enough to get you by. You should be able to do okay. Here in factoring. Now, the first thing that students often do is they solve it. This does not say equal to 0. So if I don't know what this expression, what number it represents, I can't figure out what x is. When it says factor, we can't solve it. Okay, we can't tell people x equals 2 or x equals 0. It has to have an equation to solve. We factor expressions, we solve equations. This is not an equation. Now, when I'm looking at an expression to factor, I ask myself, is it in descending order? 2, 1, 0, there's no variable there. So yes, this problem, it's in descending order. Is there a greatest common factor? Is there a number that divides every term? Can I pull out a common number or a common variable? In this case, no. That I can't. 3 and 2 are prime with respect to each other. So if I have it in descending order and I've already looked to see if there's a common factor, I'm now ready to apply your X method that you like so well, that works very well for you guys. The only caution that I have, when you draw your X, if you have a minus sign, be careful that you don't draw the X through there and make it accidentally later on look at it and think it's a plus sign. If I had a line going through there like that, I might not be able to read my own handwriting if I'm not writing very neat. You take the first term and the last term and you multiply them together and you put that at the top of your X. You're now playing a puzzle to where you're looking for two numbers that when multiplied together give you the top number, but when added together give you the bottom number. And you may have to come over on the side and play around with some possibilities. You might think, well, I'll try negative 15 and positive 1, and of course they each have x squared, or excuse me, x to get x squared. But when I add them together, I get a negative 14. I'm looking for a negative 2. When the numbers do not have a lot of different possibilities, you guys are pretty fast at recognizing that I need a positive 3x and a negative 5. Because when I have the positive 3 and negative 5, I get negative 15. But when I take positive 3 and add negative 5, I get negative 2. So now, let's take this and go to a clean, we need more space to work. So we make a table. And in the table, we fill it in diagonally. The first diagonal is for the first term and the last term of the problem, the 3x squared and the minus 5. The other diagonal are the two numbers that we found from the x. Now it doesn't matter on this diagonal if I put the 3x at the bottom of the diagonal or up at the top, as long as it's on that diagonal. So now we look at it horizontally, say first, and say, is there a number, is there something common to both of these numbers in the box? Well, there's not. If I look vertically here, is there something common? Yes, a negative 5. And then we check, is positive 1 times a negative 5 equal to negative 5? Yes. So now we look at this, say if you look at it vertically here, I see a 3 in both places. I know a 3 is common. I see an x to the first. Hey, I have an x to I have more than x to the first there. 3x is common. And 1 times 3x is 3x. Now I look horizontally here. 3 and negative 5 don't have anything in common, but they both have an x in those expressions. And 1x times 3x is 3x squared. 1x times negative 5 is negative 5x. 1 times 3x is 3x. And positive 1 times the negative 5 is negative 5. So we have completed the table. So you say, well, so what? What did that give us? Well, it gave us our answer, because we're trying to factor this trinomial. And now we can write it as a product of two binomials, and we have those on the left side and up at the top of our table. So we have a 1x plus 1. We have a 3x minus 5. So if you have time and you are wanting to check your work, you would make a table in the reverse order. You would say, if I have x plus 1 and I have 3x minus 5, and I multiply the outside values and fill on the inside of my table, will I get this same trinomial? You know, you get that 3x squared. You get the 3x minus 5x and negative 5. And when you write those down along this diagonal, those are like terms. 3x plus a negative 5x is negative 2x. So your answer checks. This is our final answer. All right, let's move on. For problem number 4, factoring. Now, when I first gave you this problem, I had a typo. I think I had a negative sign there, and you guys caught it, so we changed that. So make sure that on your paper or on your solution that you have a positive sign there, because otherwise you can't factor it. And I wanted to give you the ones on the quiz you'll be able to factor. There's none of them that are prime. You'll be able to factor each one. All right, again, we don't have an equation. It does not say solve. It says factor. So I can't tell people what the value of x is. Are the terms in descending order? It's 4. And then now I am missing a cube term, but I got x to the 4th. I don't have an x cubed. I have an x squared. I don't have an x. The terms are in descending order though. It is going 4, 2, None. Do the terms have a greatest common factor? Well, no, because here's a 1 and 13 doesn't divide the 36, and we don't have a variable in every term, so it does not have a greatest common factor. I can apply the x method if I have 3 terms, and if I look at the biggest exponent and look at the next exponent, the smaller, it's half of it. Half of 4 is 2. So the middle term will have a degree that's half the degree of the leading term. Then I know I can apply the x method. Alright, so let's give ourselves some room. Did I do that on the next? Nope. Alright. So I'm going to apply my x method. Be careful. Again, we have a minus sign there. I don't want to accidentally draw a line through that and then misread it as a positive sign. The first term times the last term gives me 36 x to the 4th. I'm looking for two numbers that when I multiply them together, I get a positive 36, but when I add them together, I get this negative 13. So I know both numbers are going to be negative. A negative times a negative is positive, and a negative plus another negative is just more negative. Now, when I think and I play around with the numbers, the negative 9 times a negative 4 will work, because negative 9 times a negative 4 is a positive 36, and negative 9 plus negative 4 is negative 13. Alright, so now, when this is a 1, I don't necessarily have to create my box. It's easier than that. When it's a 1, I just come in. You know, maybe some people, though, even though you technically don't need the box, maybe you just like making it and it only takes a second. So let's go ahead and do that. When you fill in the boxes from the x method, you always enter it diagonally. So x to the 4th is on here, and 36, the first and last term, is on one diagonal. The two numbers that we found in the x are along the other diagonals. When I look across here, I say, well, what is common? Now I do notice that this diagonal has a negative sign and a negative sign, and this number is positive, so I'm going to need those outside numbers to be negative, because a negative times a negative is positive. And 9 divides 36, so it's common. Alright, here 4 divides 36, so it's common. And a negative 9 times a negative 4 is a positive 36. Now, when we look across horizontally here, with the 1 and negative 4 don't have anything in common, but hey, they both have an x squared. So we factor out an x squared. When I look vertically here, the numbers themselves don't have anything in common, but the variables do. That's an x squared. So x squared times x squared, you add the exponents. 2 plus 2, this is x to the 4th. Negative 4 times x squared is negative 4x squared. Negative 9 times x squared is negative 9x squared. And a negative 9 times a negative 4 is a positive 36. So we've done it. Alright, whoops. Well, I want to get that out. There we go. I want to get that out of my way a little bit. This trinomial factors into the two binomials x squared minus 9 and x squared minus 4. But you can continue to factor this. X squared minus 9 9 is 3 squared. So whenever the first is squared and the second term is squared here, you can factor that to x plus 3 times x minus 3. I know you've seen that before. The same thing here. X squared minus 4 is the same thing as x squared minus 2 squared. That's x plus 2 times x minus 2. That's our final answer for number 4. Number 5, it's asking us to solve an equation. So we are going to factor it, but after we factor it, we're going to keep going and tell people what x equals. Are the terms in descending order? 3, 2, 1. Yes, they're in descending order. Do I have a greatest common factor? All of these numbers are even, so I know they have a common factor of 2. I see an x in every term. So yes, it has a greatest common factor, and we have to pull that out from each term. So we're going to factor out a 2x. Now, when we do that, here, let's do that on another page to really illustrate how to do that. I can rewrite this as 2 times x times x times x. I can rewrite this as 12 times 2 times x times x. I can rewrite this as 28 times 2 times x. That equals 0. Well, notice that I have a 2x in the first term. I have a 2x in the second term. I have a 2x in the third term. That's why we say it's common. If I factor that 2x out, I don't write it now. It's taken care of out here in all three places. So when you pull that out, what's left is x times x. We write that as x squared. When we factor out the 2x, we pull that out. What's left is 12 times x. This 2x, we pull it out, and what's left is minus 28. So we have a theorem that is called the zero product theorem. When you have an expression written in factored form, and it's one equation, you can split it up and make it more than one equation. My first equation, I take each factor, this 2x, and I set it equal to 0. I take this second factor, x squared plus 12x minus 28 is equal to 0. And I solve each equation. The 2x equals 0 is very easy to solve. Divide both sides by 2, and then you have x equals 0. Or you just think about it and say 2 times 0 is 0. So here is one of my answers I know for certain. Now over here, I apply the x method. Because I have 3 terms, this is 2, half of 2 is 1. My exponents, the biggest exponent is twice the smaller one. I take the first term times the last term and put it up at the top of the x. Now I have a puzzle that I have to think of 2 values when multiplied together give me this top expression, but when added together give me the bottom. So with it being negative, I know that one of the numbers is positive and one is negative. When you add them together, the positive has to be the bigger of the 2 numbers. So if I have 14x and negative 2x, will that do the trick? Positive 14 times a negative 2 is negative 28. 14 plus a negative 2 is positive 12. So that did the trick, and we found it. Alright, so in our table, along one diagonal is x squared minus 28. Along the other diagonal are the values we found in our X puzzle. When I look at this horizontally, I can see that negative 14 is, positive 14 is common to both. When I look at this vertically, I see a negative 2 is common to both. And a positive 14 times the negative 2 is negative 28. So I haven't made any mistakes yet. If I look across here, I see an x in both of these terms, so I can write an x out here. If I look up and down, I see an x in both of those terms. So x times x gets me x squared. Negative 2 times x gets me negative 2x. 14 times x gives me 14x. And we already said that positive 14 times the negative 2 gives me a negative 28. So now we can solve this equation that we have here on the right. Originally it was a trinomial, and it was difficult to see what would cause 0 with that arithmetic. But now we've rewritten the expression in a way where it's easier to see what would cause this value to be, this expression to be 0. If x plus 14 were equal to 0, then the whole thing would be 0. You'd have 0 times x minus 2. Hey, that's 0. On x minus 2, if it were equal to 0, x plus 14 times 0 is 0. So we solve for x by doing the opposite. The opposite of adding 14 is to subtract 14. And x is negative 14. We add 2 to each side because that's the opposite of subtracting 2. And we have x equals 2. We have three answers: 0, negative 14, and positive 2. Our degree was 3. We can't, there's no more answers. We found them all. Let's take a look at this one. It's another solve. So yes, we're going to factor in order to solve it, but our final answer is going to be able to tell people x equals some number, unless it would have no solution. But these on this quiz will have solutions. Are the terms in descending order? Yeah, 4 and 2. Does it have a greatest common factor? Yes, because 4 divides 64 and x squared is in both of these. So again, let's come over and look at this in more detail. We don't want to make silly mistakes. It's okay to write extra steps in there. I'm going to look at this 4x to the fourth as 4x squared times another x squared, because 2 plus 2 is 4. I'm going to look at this 64 as 16 times 4. If you don't believe me, come up to a calculator, and 16 times 4 is 64. And then I have x squared. So in this term, I see a 4 times an x squared. In this term, I see a 4 times an x squared. What I've highlighted there is common to both terms. If we pull that out, if we factor out the 4x squared, inside parentheses, we're still going to have that minus sign. We're still going to have two terms, but this first term now only has x squared that's remaining. And in this second term, it only has the 16 that's remaining. Alright. We have this in factored form, so we can split apart the two equations. 4x squared is equal to 0, or x squared minus 16 is equal to 0. Here, if I divide each side by 4, x squared is equal to 0, and it's only 0 times itself, or if you take the square root of both sides, 0 times 0 is 0. Anything else, 1 times 1, 2 times 2, negative 1 times negative 1, all those other values are going to be something different than 0. Now over here, 16 is a perfect square. It's 4 squared. So we have x plus 4 times x minus 4. That's in factored form. We split it into two equations. X plus 4 equals 0, or x minus 4 equals 0. Here we do the opposite. Instead of adding 4, we subtract 4 from both sides. 0 minus 4 is a negative 4. Instead of subtracting 4, we do the opposite. To get the x by itself, we add 4 to each side. 0 plus 4 is 4. So we have 3 answers in our... now our biggest exponent was 4. And you say, well, I was expecting 4 answers. You see this 2 right here? This guy actually counts twice. So we have x equals 0, another x equals 0, and then negative 4 and positive 4. We have found all the solutions. Sometimes they'll refer to this as a repeated solution, because when we factored it, we got it down to an x squared. These guys, we got it down to an x to the first. Now look at this. We have an equation, so we'll be able to tell people what x equals. And they've done the hard stuff for us. It has already been factored. All right, that should make you smile. Now we use the zero product theorem. This first factor, x plus 1, we said it equaled to 0. And the second factor, 2x minus 1, we said it equaled to 0. The opposite of adding 1 is to subtract 1. 0 minus 1 is a negative 1. Here we add 1 to each side. That'll give me 2x is equal to 0 plus 1 is 1. Now we divide both sides by 2. 2 divided by 2 is 1. And I have 1/2. So I had 2 factors. I have 2 answers. X equals negative 1 and x equals positive 1/2. All right, drum roll, the final problem here. It says to solve, so I'm going to tell people what x equals. Once I factor it, I have to keep going. Are the terms in descending order? Well, yeah, kind of. I've got 2, 1, and a constant term. But look at this 6 right here. That's going to cause me some problems. I'm going to have I want that to be on the other side. I need to subtract 6 from both sides of the equation. So were the terms, yes, it was in descending order. No, it did not have a greatest common factor. But when I say yes to this, really I need to subtract 6 to this. So maybe, you know, it's kind of a yes. Yeah, 2, 1, 0, but that negative 6 is over there. So it'd be better if this were x squared plus 3x minus 18 is equal to 0. So not only now do I have it in descending order, but I have it in a standard form. Okay. Do the terms have a greatest common factor? Well, this is 1, 3, and negative 18. No, there's no number, and I don't see an x everywhere. I see them in the first 2 terms, but not in the last term. We can apply the x method on the left-hand side to get it in factored form, and then set each factor equal to 0 and find our 2 answers. Since this is of 2, we're expecting 2 answers. So let's come over here and we have our x squared plus 3x, and I think it was minus 18, but I better check that. Yeah. Now we apply the x method. And maybe people like putting a 1 here. The first term times the last term, negative 18x squared. So since it's negative, one number is going to be positive, one number is going to be negative. Since this middle term is positive, the bigger one is going to be positive. So positive 6x times the negative 3x ought to do the trick. Let's make a table. the diagonal, or my first term, 1x squared, and my last term, negative 18. Inside the x, the numbers that we found were 6x and negative 3x. So we factor each one of these. So here, what's common to both is the number 6. Here, what's common to both of these, the common factor, is a negative 3. And positive 6 times a negative 3, negative 18. When I look here, these both have an x in common. When I look vertically here, these both have an x in common. Let's check. X times x is x squared. Negative 3 times x is negative 3x. 6 times x is 6x. And positive 6 times the negative 3 is negative 18. So this trinomial factors to a binomial times a binomial. X plus 6, x minus 3. When you have it in factored form, you have the zero product theorem. If these two values multiply together to give you 0, then either x plus 6 has to represent 0 or x minus 3 has to represent 0. Subtract 6 from each side. Add 3 to each side. There's our two answers, and we're done. Now, I took a lot of time. You'll be able to do your quiz much faster than when I did it because I was talking a lot as I went through it. I was explaining those patterns from the notes from the synthetic division. You have to know this well enough to be able to do it quickly and efficiently. So I hope this helps, and I'll talk to you later.